Okay, so some of the things on the exam I'm just going to list out. Some of them I will actually do examples of. The first ones here I'm just going to list out. You need to be able to reduce a fraction. In other words, if I give you something like 9/12, you need to be able to look at that and say both of those divide by 3. Give me 3/4. You'll need to be able to convert from a mixed number to an improper fraction. And back again. Which is something we've done quite a bit today in our problem solving. You'll need to be able to add, subtract, multiply, and divide fractions and mixed numbers. So I'll pause right there. Any questions on that part so far? Any of those that you want to see an example of or struggle with? Okay. Have I showed you guys the ABC key on the calculator? Okay. So far, most of what we've done up here can be done with the calculator if you use the ABC key for the operations. The reducing fractions can be done with the ABC key. Converting mixed numbers, you should have a key. It's usually a second function that looks something like this. That'll actually convert a mixed number to an improper fraction and back again. Okay, we need to be able to solve basic equations. And by basic equations, I mean really simple, like 3x equals 21, or x minus 9 equals 14, or even 7x plus 2x equals 99. Equations like those. Then reducing ratios. Maybe if I say that last year, 27 out of 36 students in this class passed. What ratio was that? Create that ratio. So that'd be 27 out of 36, and both of those numbers can be reduced. Both those can be divided by 9. Give me 3 out of 4. Be able to tell the difference. If I ask what is the ratio of passing out of total, let's look at this. If I ask, passing out of total is what I just showed. Passing out of total students. But I might ask, what's the ratio of passing to failing? Then I have to be able to create that other ratio. Passing is still 27. How many failed? Well, out of 36, if 27 passed, 36 minus 27, or the other 9 had to fail. So 27 out of 9, or I can reduce that to a 3-to-1 ratio. If I give you a proportion, I need to be able to find the missing number. I might have x over 7 equals 12 over 21. Find x. Well, in this case, since x is by itself here, I can just cross multiply and divide. 7 times 12 is 84. Divided by 21 is 4. So x is 4. But if x is not by itself, I might have something like 8 over 5x is equal to 2 over 5. So here, since x is not by itself, I can't simply cross multiply and divide. I have to full out cross multiply. So I multiply this diagonal. 5 times 8 is 40. And I multiply this diagonal. 2 times 5x is 10x. And those two cross products, or those diagonal products, have to be equal. So 10x has to equal 40. I solve for x by dividing by 10. X equals 4. Or I can use ratios for solving problems. I might say that Pete travels 105 miles on 5 gallons of gas. How many gallons will it take for Pete to travel 336 miles? Well, we had 105 miles and 5 gallons. 336 miles has to go, 6 miles. Has to go on top because the miles have to go together. So on bottom, what we're going to look for is gallons. Cross multiply and divide. 5 times 336 divided by 105 is what? 16, I believe, gallons. Any questions so far? Okay, and then the part that I'm sure needs a little bit of review, factoring. If I ask you to prime factor or factor completely, they both mean the same thing. If I give you 120 and ask you to prime factor, that's where we do our factor trees. 120 can be divided by 10 would leave me with 12. Now you could do 2 or 3 or any other number you see here. It ended in 0, so I saw the 10. 10 can be split into 2 times 5. Both of those are prime. 12 can be 3 times 4. The 3 is prime. The 4 is 2 times 2. So 120 is 2, 2, 2. So 2 times 2 times 2 times 3 times 5. That's the prime factoring of 120. If I ask you to prime factor (24) x to the third p squared, I'm going to prime factor the 24. 24 is 4 times 6. 6 is 2 times 2. Sorry, 4 is 2 times 2. 6 is 2 times 3. So that means the numerical part is 2 times 2 times 2 times 3. X to the third is just 3 x's, and p squared is p times p. So So that is factored completely. Does that look familiar? Any questions on factoring? Okay. Then I'll ask you to find least common multiples. Least common multiples, you can either just make lists if I have numbers. So if I give you something like 21 and 15, you can go ahead and make lists, counting up by 21s, 21, 42, 63, and so on. 15s, 15, 30, 45, 60, and so on. Or we can factor. 21 factors into 3 times 7. 15 factors into 3 times 5. And then we look at what they have in common. They both have a 3. What does the top one need? It needs a 5. What's the bottom one need? A 7. So now we got 3 times 7 is 21, times 5 is 105. 3 times 5 is 15, times 7 is 105. So the least common multiple is 105. If we throw variables in there, (18x to the 5th y) and 15x squared y to the 3rd. I can factor the numbers. 18 is 2 times 3 times 3. 15 is 3 times 5. They have a 3 in common. What's the top need? 5. What's the bottom need? 2 times 3. Good. So I'm going to multiply that out. 2 times 3 is 18, times 5 is 90. Same over here. 3 times 5 is 15, times 2 is 30, times 3 is 90. So 90 is the number. What do we do with the variables? For each variable we take, it's either the highest power or the lowest power. Which one is it? It's the highest. So x to the 5th and y to the 3rd. Remember, for its greatest common factor, greatest common factor, we take the lower power. If it's least common multiple, we take the higher power. Then you'll need to be able to add, subtract, multiply, and divide with our fractions. You might be asked to do something like this. 5 over 8x plus 3 over 4x. What's my common denominator going to be for the numbers? 8 and 4, common denominator would be 8. They're both x's, so we don't need to change the variable. So the 5 over 8x is just going to stay 5 over 8x. 3/4, or 3 over 4x. 4x had to be multiplied by 2 to make 8x. So 3 times 2 is 6. So now what? 5 plus 6 is 11 over 8x. Or we might have 5/6 plus 3 over 4p. It's the same type of thing. 5/6, 3 over 4p. For the numbers 3 and 4, my common denominator would be 12. This one has a p though, so this one needs a p. What do I multiply 6 by to turn it into a 12? 2. And I need to put a p in there, so I'm going to have to multiply by 2p to make it 12p. So 5 times 2p is 10p. What do I multiply the 4 by to make it a 12? 3. It's already got a p, so I don't need to multiply by any variables. 3 times 3 makes 9. So now 10p over 12 plus 9 over 12, or 10p over 12p plus 9 over 12p. We add the counts. 10p plus 9 is just 10p plus 9 all over 12p. Any questions so far? This looking familiar? Okay. You'll need to be able to multiply something like 5x over 9 times 3 y squared over x to the third over 10x to the third. Let's do. So now I could just multiply this out and reduce. It's probably the easiest way to do it. 5 times 3 is 15. X times y squared is xy squared. 9 times 10 is 90, just the x to the third. So now to reduce, I have 15 over 90. What can both of those be divided by? 5 works. 15 divided by 5 is 3. 90 divided by 5 is 18. Are we done? No, they can both be divided by 3, which means 1/6. So numerically, I have 1 over 6 here. Where does x go? Bottom, because the bigger power is on bottom. What power is it going to have? 2. Good. This is x to the 1, so 3 minus 1 is 2. Where's y going to go? Top, and this is y to the 2. There's nothing to cancel with it. So 1y squared over 6x squared, or you could get rid of the 1 and just have y squared over 6x squared works too. You may have to divide something like 8p over 9v squared divided by 4p to the third over 27b. Like that. So first thing I have to do when I divide is what? Flip the second fraction. So this becomes times. Now it's 27b on top, 4p to the third on bottom. So 8 times 27 is 216. P times B is going to be BP. 9 times 4 is 36. That'll be B squared P to the third. So I've got to reduce my 216 over 36. Can I make that a mixed number? See, no. No, because I got variables there, and I don't know what value those variables have. But I can divide both of them by what? Well, I see 2. They're both even. That's 108 over 18. Am I done? No, I can divide both of them by... Still even, so let's do 2. 54 over 9. Am I done? No, both of them can be divided by 9. 6 over 1. Now how about my variables? Where's the b go? Bottom, what power? Just b, or 1, right? 2 minus 1 is 1. So it's b to the 1 or just b. Where's my p go? Bottom, power of 2. Good. 3 minus 1 is 2. So 6 over 1bp squared, or just 6 over bp squared. Those looking familiar? If I raise a fraction to a power, remember what I'm doing is I'm taking each piece. So 2 to the power of 4 over 5 to the power of 4. So 2 to the 4th is 16. And 5 to the 4th is 625. So 16 over 625. Any questions there? So, 2x to the 4th over 5m squared p, all squared. Now, first thing we should do is, if we can, we should reduce anything in this fraction. Is there anything in that fraction that can reduce? No. So now we're going to take each piece to the power. This is 2x to the 4th squared over 5m squared p squared. Now, when we take a power, the count, or the number, still has to go with that power. What is 2 squared? 2 times 2 is 4. X to the 4th squared, remember when we have a power of a power, we do what? Not add, you multiply it. Yeah. If it was multiplying two exponents, you'd add the powers. If we're taking a power to a power, we multiply. 4 times 2 is 8, so that's x to the 8. So down here, 5 to the power of 2. 5 squared, 5 times 5, 25. M squared to the power of 2, m to the 4th, and p to the power of 2. This is p squared to the power of 2, right? And we think that is 1, 1 times 2 is 2. That's it. That's as far as we can go with that. Then we have solving the equations like we did tonight. Solving those equations with fractions in them, like we did in our first hour. And then, like we had for our problems at the beginning of the first hour, solving complex fractions. So it might be order of operations with fractions, or it might be that double fraction, the fractions within a fraction that we did at the beginning of the class. If I give you something like this, what is that telling you to do? It's written kind of funny here, but all that is saying is this. X to the 3rd over 18 divided by x over 6. So what we have to do there is x to the 3rd over 18 times 6 over x. Oops. I can cross cancel if I want to, but I don't have to. Let's do the 6's there. Divide out by 6, you get 1 and 3. So x to the 3rd times 1 is x to the 3rd. 3 times x is 3x. We can still reduce. What can we reduce here? The x. Yeah, the 3 is going to stay on bottom. X to the 3rd and x, well, the bigger power is on top. So x is on top. 3 minus 1 is 2, so it's x squared over 3 is what that result is. Okay, any of the stuff that we've gone over for the test that you guys have any questions on? Okay, it's a little bit early, but I'm not feeling the greatest tonight, so we're going to call that good enough for tonight anyway. That is everything that we need for the test and all of our new material. So make sure that you do the homework and the quiz tomorrow. And be ready for the test on Thursday.